absolute value graph, and you had to decide if it was going to be a solid or a dashed line, or a solid or a dashed absolute value graph. Same with parabolas, so now you're graphing a parabola, determining if it's solid or dashed. Then you had to test a point to figure out where to shade. So inequalities are the ones you have to remember. You have solid versus dashed, and you also have to shade one part, so you pick a test point, which can be 0, 0, as long as your parabola doesn't go through it. And then you test that point, determine where to shade. On here, this, just the way it copies, looks like everything is shaded. It is supposed to be the inside is shaded, the outside isn't, is what that's supposed to be. But it looks like they're both shaded equally. So just so that makes sense where it's saying what is a solution, what isn't. So let's go through an example just together. This is a good review of graphing, since that was the very first thing we did in chapter 4. It's a good review of graphing quadratic equations as well. So if we are graphing y is greater than x squared minus 3x plus 2, it says to graph the related function. All that means is you're graphing this as if it's an equation. So I'm graphing y equals x squared minus 3x plus 2. So here's the review part of this. How do I graph that? When we graphed quadratic functions, when we graphed parabolas, what did we do first? Axis of symmetry. How do we find axis of symmetry? What was it? Opposite of b over 2a. So actually, let's go back up here. What is the a value for this equation? 1. B is -3. C is 2. So opposite of b over 2a. B is -3. So opposite of b is 3. Over 2 times a is 1. So it's 3 divided by 2. Yep, 3 over 2, or if you wanted to write it as 1.5. So the axis of symmetry is the equation x equals 1.5, but on the graph, it's a vertical line through 1.5. What did we find after the axis of symmetry? Vertex. How do we find the vertex? Yeah, so the 1.5 is the x coordinate. Substitute that into our function to get the y. So it would be 1.5 squared minus 3 times 1.5 plus 2. Which 1.5 squared is 2.25 minus 3 times 1.5 is 4.5 plus 2. -1/4. So yeah, -1/4, or if you put -0.25, if you got the decimal, either one is fine. So I'd plot 1.5 and then go down about 1/4 to my vertexes. And you are, like, the goal of this question is the graph. So again, you need at least 5 points because your answer is the graph. So you need at least 5. So from here, what's the next point we usually found? The y-intercept, just because it was an easy point to find. What is the y-intercept? 2, it's your c value, so 0, 2. And actually making the table, again, that's up to you. I just need to be able to tell where your points are. We have our vertex. We have 0, 2 for the y-intercept, and that would reflect over to what other point? 3, 2. So I would say what I'm noticing, because I'm almost through grading all the quizzes, but what I'm noticing with every hour is, for the most part, the graphs are okay, but some people are not drawing in the axis symmetry, and it's not a requirement to draw it in, but why it's helpful to draw that in is then you know what you're reflecting over. So I'm just noticing students that values that aren't reflecting over the correct point or the correct line. So draw that in just as a reminder to yourself of what you're trying to reflect over. We need 2 more points. So really, we just need to find one other point. So what's an x value we could plug in? We could plug in 1. I'm going to go out of order in my table. But if I plug in 1, I'd have y equals 1 squared minus 3 times 1 plus 2. So that's 1 minus 3 plus 2, which is 0. So I have 1, 0. And that reflects over to what other point? 2, 0. Those would be the roots, yes. So if this was a solve by graphing question, where I wanted you to solve this equation using a graph, your answers would be 1 and 2. Those would be the roots. Now, before I draw the parabola in, should it be a solid parabola or a dashed parabola? It should be dashed. And this is the case. Make sure you do go all the way through the edge of your coordinate plane, because you are going to be shading an area, and you're either going to be shading inside of the parabola or everything outside of it. So you need to have 2 distinct areas of your graph. So you do need to extend it all the way through the edge if you haven't been doing that. I know I'm guilty of that. I don't always draw through the top edge or bottom edge. All right, so that's reviewing just graphing the parabola. Now, with inequalities, you also have to shade. So just like we did for other inequalities, we pick a test point that isn't on our parabola. So 0, 0, you can always pick unless your parabola goes through it, which ours doesn't. So if I test 0, 0 back in the original inequality, so put 0 in for y, 0 in for all the x's. So I'd have 0 is greater than 0 squared minus 3 times 0 plus 2, which then this side is just going to be 2. 0 is not greater than 2. This is false. So where do I shade? Am I shading inside the parabola or outside of it? Inside of it. 0, 0 is outside of it. I don't want to shade it. It's false. I shade everything inside. And that was step 3, shading the solution region. So again, you're going to have a test next Tuesday where different graphing questions, you're going to have to determine when do I shade, when do I not shade. You shade for inequalities. You do not shade for equations. So make sure you understand the difference. That's a conceptual understanding of when do I shade, when do I not shade. So what I have for you, I'd like you to flip it over to the back example and work on example 2. Just so you can get a check for yourself. Can you get the right graph? Do you remember how to graph a parabola? I'll pass out the assignment, which is just more practice with graphing these quadratic inequalities. And tomorrow we're going to be solving quadratic inequalities. And that's the last lesson for chapter 4.
Bless you.